Hello. So as part of my summative submission, I will go through the Red Bull question. So just an overview of the question. It's about Red Bull. They are producing two types, that is the apple tongue and the lemon tongue. And then the cans are in 500 millimeter cans, as can be seen here. And then some of the ingredients that are there, which will form part of the constraints, include taurine, flavoring, carbonated water. They'll form part of the constraints as the ingredients which will be used to make the apple tongue and the lemon tongue. Then as also part of the constraints, as you can see here, is the percentages by which the various ingredients will feature in the apple tongue and the lemon tongue. And then we have the maximum, the upper limit and the lower limit, as some would prefer to call it. And then the lemon thing generates profit of which gives us the objective of the whole thing, which is maximizing our profit. And the whole question is calculate the optimal solution. So I went to my spreadsheet, and this is it. So my objective, as had been stated earlier, maximizing the profit gained from the production of apple tongue and lemon tongue, with all factors and constraints put into consideration. Then the decision was, as was seen earlier, to decide on the amount of ingredients to be put. If it's in lemon, if it's for example taurine, how much of taurine will be put into lemon tongue, and so forth. So some of the decision variables, the letters I assigned to the various ingredients, and also to the objective variables. So for my model, I said that the number of liters in lemon tongue were represented by B, the number of liters in apple tongue by A, taurine by T, flavoring by F, and carbonated water by C. Therefore, BT, those ones that fall under B fall under the lemon tongue, and those ones that fall under A, the letter A will fall under the apple tongue. So for instance here, as can be seen, BT, number of liters in taurine lemon, BF, number of liters in lemon tongue. And then when you go down, for example, AC, number of carbonated water in number of liters of carbonated water in apple tongue, as can be seen there. So that one is not to be confused at any point. Then later on, as part of my assumptions, I'll note that the measurement of quantity was in liters. Yeah. So we go back to the objective function, which ties to the objective, maximizing the profit, meaning we have to check on the unit, of how much a profit will be earned from a unit. So we are told that a can is 500 ml, and each can generate 2.5 in lemon tongue. And so after we look at that, we'll now go down to the constraints, which are constraints, are limitations to the model. So when you look at the first one, no more than 20% of taurine, which means that the taurine contents in lemon tongue should not be more than 20%, meaning that it should be less than or equal to 20%. So as part of the formula that we have here is 0.8 BT, that is the taurine level in the lemon tongue, minus 0.2. This is as per the formula that we learned in example 28 of last week's reading. Yeah, at least 5% of flavoring in lemon tongue, which is it should be greater than 5%, meaning that the possibilities of it could be 10%, 20%, 30%, or so forth, as long as it's either 5 or above. Then no more than 20% taurine. It goes down that way with all the formulas adjusted to it. Then after we are done with the constituents in the various in the apple tongue and the lemon tongue, we go to the supply, the total supply. This applies to both the apple tongue and the lemon tongue. Like if it's 2,200, it applies to both. So the supply of taurine was 2,200, which is so when you add, it should be less than or equal to that number. It should not surpass that number. Supply of flavoring was 2,300. Supply of carbonated was 4,500. And then as part of the other constraint mentioned was the availability of taurine. The taurine must be more than a quarter. The available taurine, a quarter of it must be used in the manufacturing of the apple tongue. So I also put that into consideration. And then finally the non-negativity constraint, meaning that the decision variables here, the A and the B, the apple tongue and the lemon tongue, should not be less than 0. because at that point maybe we won't be producing anything. So it's 0 or above. Yeah. So that's it. So since a can is 500 ml, I therefore double the profit. Therefore the profits in lemon ting will be 5 and 2 will be which were formerly 2.5 and 2.3, they'll become 5.0 and 4.6. That is per unit. That's per liter, as I had stated earlier. Each unit is a liter, and it will give me 5.0 and 4.6 dollars respectively. Then okay, from there I went to my model. I decided to create my model, taking into consideration some of the learnings we had done and also from the example we were given. So this is how I put down my decision variables. As you can see, the decision variable here. So the decisions variables represented under the taurine, the flavoring, and the carbonated water under lemon ting, and then the taurine, flavoring, and carbonated water under the apple ting. Then the decision variables will fall here. So this will form part of the objective variables that will be changing when I open the solver. Yeah, they'll fall under here. Then this one is the profit per unit, which are in liters. I put them under here. And as we were informed, under the lemon ting we'll have $5 per unit, 5, and then 4.6 under the apple ting, which fall here. So the sum product of it will give me the optimal solution, as can be seen here. The sum product of all this and all this will give me the optimal solution, which is the profit, which will appear here after I open the solver. And then I also listed down the constraints. I made sure I put all of them in order, and like as can be seen here. For example, let's take taurine ratio in lemon ting, which was 0.8 as was seen in the formula we had here. You can see here 0.8. That's the taurine that falls under the lemon ting. As you can see, there it is. Then the rest so that one is only for the lemon ting. Then the rest which fall under the apple ting will have zeros, and zeros, as can be seen there. Same to the flavoring in apple ting, negative 0.05, 0.95. It all falls under the formula. It follows the formula. Follows the formula. And then at the end of it all, in the left hand side, you find the sum product, as can be seen here. You do notice it's the sum product even when you check here. Yeah, that's it. So you go down. As you do it, you make sure all the constraints are there. So I made sure all the constraints are put into consideration. Yeah, then also the taurine supply, the flavoring supply. So after I did that, after opening my solver and ensuring everything is correct, I remembered to put the non-negativity constraints here. When you click the option button, and then the simplest way is by going down here and just clicking out it here. Okay. Then after it all comes in order, then you simply click on solve, and then it gives you whatever you want. That it changes this part from the objective variables, and then the maximum profit, which is now our optimal solution. After I was done with that, I recommend I did the recommendations and conclusions. Sorry for the glitch. So recommendations and conclusions: in order for Red Bull Cooperative to realize a maximum profit, which is USD 41,400, they will need to adhere to the following, as I had stated there. In lemon ting, they should use 1,150 liters of taurine, 2,162.5 liters of flavoring, and 2,437 liters of carbonated water. This is in accordance to what we had found here. As you can see, it corresponds to what we had found in our model: 1150, 2162.5, and 2437. Yeah, so it's also the same to the apple ting. And then lastly, from this information you can draw the conclusion that carbonated water is the most feasible ingredient, while taurine is the least feasible when you look at the amounts that were used. And then some of the assumptions that I made is that the currency I used is in dollars, and the quantity of ingredients is in liters. and then all this is carried out in consideration of all factors and constraints. Yes, here it is in liters. The quantities of ingredients is in liters. There's a bit of error there, but it's okay. It's in liters. Sorry for that. Sure thing. So that's how my model was, and that's how everything was put into together. Thank you so much. So after I'm done with the first part, I'll go all the way to the sensitivity analysis, where we are told from the information given below, these ones here, how will an increase in the minimum amount of taurine used in apple tongue increase from 550 liters to 600 liters affect the optimal solution? So there's an increase in taurine from 550 to 600, and then how will this affect the optimal solution? So what we put into consideration here, since it's increasing, we'll look at the allowable increase. From the information given, our allowable increase is 78.57, and just as a reminder, the allowable increase is the amount which it's the range at which when it's between that range, it won't affect the optimal solution, won't be affected. So it can increase by 78.57 liters without the optimal solution being affected. So when we come here, it's increasing from 550 to 600. That is a difference of 50 liters, and yet we have an allowable increase of 78.57. So the optimal solution here in this case will not be affected. So that's how my answer was. So an increase in the minimum amount of taurine from 550 liters to 600 liters will not affect the optimal solution. This is because the difference between 550 and 600 is 50 liters, yet the allowable increase is 78.57, and thus the shadow price here will not be affected. With this, we can safely conclude that by increasing the minimum amount from 550 to 600, the optimal solution will not be altered with, because it will still be within the allowable increase. Yeah, thank you.